So the headline is building production-ready event-sourced Node apps with Ralph Loop and AI. The first task was, can I build a headline for a webinar purely out of buzzwords? Yes, I can. Look at that. It's beautiful. Worked beautifully well. So what I want to show you today is just a little bit what happened in the last few weeks. I was asked by a client, can you build a Node app with can you build an event-sourced Node app? And it turned out, yes, that works beautifully well. And yeah, we had limited budget, limited resources. And what you see today in this webinar is just what came out of this, how we built this. And I just want to give a little bit of project feedback, how that worked out. So yeah. At the end of the workshop, you'll get the full setup you see in this workshop. So it's ready to use. You can start building in less than a minute. You can just check it out, run the Ralph Loop, what the Ralph Loop is, you will see during this webinar. And then it will just start to build, hopefully. So stay until the end. It might be worth it. And what you also see in this webinar, I'm not sure if you are familiar with event modeling, but I will show you two real-world event models which have a decent size. So it's typically when you work with event modeling, you oftentimes see small examples. I show you some real event models from real projects, and then you see how big they can get and how typically I structure them. So who am I? If you don't know me, I'm Martin. I wrote a book. It's called Understanding Event Sourcing. And basically what you see here in this webinar today is exactly what is written in this book. Typically, I am not a Node guy. I made a few Node projects, but most of my projects are on the JVM. I work with Java, I work with Kotlin, I work with the Spring framework, and I work with the Axon framework. That is my typical stack. But this time I work with Node, and guess what? The same patterns I use on the JVM apply to the Node project. It's the very same thing. And it's all written in this book. The whole process is written in this book, and the patterns in this book apply to any tech stack. And this is really the proof. So my whole career, I worked in the education space. I trained more than 1,500 people, many of them in person. So I'm giving workshops all the time, helping companies adopt event modeling, adopt event sourcing. That's really what I'm really passionate about. That's also why I wrote this book. And what I really love about giving workshops is the feedback. That was Mackie. He gave a feedback, and he called me the defogger, and I really like that because after the workshop, it seemed like some of the fogs got cleared. So as I said, I help companies adopt event modeling and event sourcing. It's still a niche, but we get quite some traction with all those beautiful patterns event modeling and event sourcing provides, because it's an enabler for AI. If you want to work with AI, you need well-structured systems, and event modeling and event sourcing, they allow you to give this structure to systems. And you will see today how I structure those systems and why it works so well. So yeah, when I'm giving workshops, many people come to me after that and say they had these aha moments, especially when we talk about the systems. Oftentimes what happens is the people realize the system we are building, we don't need to build this at all because it doesn't make sense. That's the best outcome you can get out of a workshop. Okay, today, what I will show you today is how we break down a system into small building blocks without writing hundreds of Jira tickets. So if you work with event modeling, your Jira tickets are either non-existent, or if you still work with Jira, typically they are just headlines, no details, because all the details are in the event model. And I will show you how to break down those systems. I will show you also how I clearly define what each of those building blocks should do without spending weeks in requirement meetings. I will also show you how to prepare 80% of the code structure without spending a single token of your AI budget. What I do is I combine AI code generation with static code generation, and this gives really good results. I will also show you how I use AI agents to build the rest, more or less on autopilot. I'm using a technique called the Ralph Loop. Most probably you've heard about the Ralph Loop. It's been everywhere. But yeah, I will just show you how I apply it and why it's such a beautiful combination with event modeling. So, and what you will see is agents love what we are doing with event modeling. They absolutely love it because it's exactly the level of abstraction they need to work. So the architecture I will show you today runs exactly like this in production for many systems. and now also on different stacks. So, for example, the Node stack. The stack that I will show you today is, of course, event modeling for specifications. We use Emmet for event sourcing. Emmet is a Node event sourcing framework. It's open source, freely available. We will use that. Of course, Node is the runtime. We use Express as an API layer and React for the client. That's the whole stack. And this is a dead boring stack. And that's exactly what it should be. Typically, my source code and also my projects, they are dead boring. They do the same thing again and again and again. And if you look at the source code, it's really a boring thing. And that's exactly what it should be. Writing creative code is not my job. I write very, very boring code, and I'm doing very well with it. Let me give you some background quickly before we jump in. What does that actually mean? Why do I talk about event modeling all the time? Why do I talk about event sourcing all the time? And why did I write this book in the first place? Back in 2021, I was really, really annoyed with our whole industry, how most projects I was involved with worked. I couldn't take it anymore. I was really, really annoyed with all this. And I really thought about quitting the industry, at least thought about quitting the whole development space, maybe becoming some kind of an agile consultant or something. I was just annoyed. But then just in time, I read an article. And this article changed really everything for me. It was one article I've read, and this article changed how I look at systems, how I think about systems. It changed literally everything. And it was the article that introduced event modeling. And this was really the missing piece I was looking for. That was missing. It was the missing piece. So it was really one single article. And I remember very well when I read this article, I couldn't sleep. I read this article and thought this was exactly what I was looking for. Because finally, it all made sense. It all started to make sense. The problem in most projects I was involved with was never technology. So we couldn't solve it with technology. No matter how well you design your microservices, no matter how well your code is structured, no matter how much you think about architecture, the root of the problem was never technology, and we cannot solve it with technology. When I understood that, everything changed. So what's the real problem? 95% of all successful software systems, they suffer from feature explosion. Feature explosion. Why are only successful projects? Because nobody is adding features to unsuccessful projects. But if you have a successful project, typically what you do is you add one feature after the other. Customers request new features, and you add one feature after the other. The more features we add, the more coupling we get, right? That's physics. That's a law of nature. At least so I thought. That's what I thought. Well, just if you add more features, the more features you add, there's more source code, more stuff you have to take care of. You have coupling in your source code, coupling in your whole code base. You need to change more things. I really thought that's what it is. That's what software projects look like. But that's a lie. That's not true. There's a different way to do that. And this is also the big enabler, if you ask me, the big enabler to work with AI in your code base. I will show you what that means. That's the typical curve you see in most projects. So the longer you work in the project, the more expensive each feature gets. You need to the features get bigger and bigger, but you don't necessarily deliver more value. And if you look at the cost curve, the longer you work in the project, just the more you need to pay for it. That's just how most projects look like. The problem with this is deadlines move, which means we miss planned campaigns, we break our deadlines, and we break our launch dates. And everything becomes super expensive. And this repeats again and again in most projects. Budgets explode, and this can kill a project before it's even launched. I've seen this multiple times. The root of the problem, though, is bad communication, bad requirements, and wrong assumptions. This triplet is really the horror for every project. The most expensive mistake you can do, build the wrong thing. And this happens again and again. You build the wrong thing because people don't communicate, people don't talk to each other, and you think you understand the problem you're trying to solve, but it's not the case. Oftentimes people don't understand the problem and they build something just to realize a few months into the project, well, this is completely wrong. We solved the really wrong problem. And that's the most expensive mistake you can make in any project. Building the wrong thing is the most expensive thing you can do. Misunderstood requirements typically lead to wrong features being built, which typically lead to expensive rework, which lead to your first cracks in the architecture. And no matter how good your architecture is, if that happens, typically you are already declining. There's nothing you can do about it. But what about AI? Everybody's talking about AI, right? Everybody, at least on LinkedIn. If you leave LinkedIn, the bubble is not that big. But if you are on LinkedIn, that's crazy. Everybody is talking about AI. Well, if you ask me, whatever you have right now, AI just multiplies it by a factor 10, at least. You could also say by a factor 100 or by a factor 1000. So if your current architecture is chaotic, with AI, you just get 10 times more chaos. If you have a well-structured architecture and a well-defined process, AI just makes you 10 times faster. So it's just a multiplier of what you already have. Typically what happens when you start using AI is you prompt something, well, build me this, and you hope to get something out of it. Typically that happens, you get something, but this what you get is typically not maintainable. At least if I work with this like AI, with AI like this, what I get is a whole bunch of code typically, and the more you prompt, the more code you get. It's really crazy, and this didn't change with the newer models. So this is still the case. You get a whole lot of code, and typically much more code than you need to solve a problem. And the result is typically a whole lot of coupling in the code. Coupling is the big problem in most code bases. It's not how you structure it, it's really coupling. Coupling is the big problem. And also the problem that most agents face when they get into those code bases. What AI truly needs is clarity. You need a lot of clarity in your code base. Clarity means structure, clarity means modularity, but clarity also means very, very clear requirements and instructions. Typically, you don't get clarity with better prompts. I see a lot of teams right now trying to improve their prompts and everything, but if your code base is not well structured, no prompt will help you. That's at least my experience. You can invest a whole lot of time in your prompts. If the code base isn't ready for AI, no prompt will really help. And what also will not help is if you put more markdown files into your code base. Not sure what your day looks like nowadays, but just a few years ago, my job was to manage code, structure code. Nowadays, it's more like manage a whole lot of markdown files. At least in many projects that happens. I'm not sure I really like that. Managing markdown files is really not what I want to do all day. But right now, this really happens almost everywhere. Everybody tries to get those instructions ready for AI using markdown files, different agents, MD, Claude MD, and skill files, whatever you need for your AI agents. As I said, but you can't build a stable AI on a broken foundation. This simply doesn't work. AI breaks when small changes cascade through your code base. And that's just another word for coupling. Coupling is, no matter which problem you face in your code base, it almost always boils down to coupling. Coupling is really the root of most problems you face. And then I hear people say, hey, what about the new token window? Oh, we have Opus 4.6. It has a 1 million token window. This doesn't really help. And I can tell you, I wasn't impressed at all by a 1 million token window because I don't need that. If your code base is well structured, you shouldn't need a 1 million token context window. Think back about Bill Gates. He said 640K ought to be enough for anybody. Well, if you translate this to today, how much context is enough for everybody? How much context do you really need? Well, I think we are still looking for the answer to this, but it's not necessarily more is better. I don't believe that. So, where does this all lead? Why am I talking about all those problems you most probably know already? Where does this all lead? Well, let me tell you a different story. What about, and it's the same thing that is in this book, so it's the very same story. What if we describe a system in great detail? But we do it in a language that anyone understands, including your AI agents. So if we can describe a system in a language that both your engineers understand, both the business people understand, and also your AI agent, it's the same language for anyone. Wouldn't that be beautiful? What if we use only 5 key elements and 4 patterns to describe any system in the world? That's exactly what event modeling is. It's a very simple pattern-based language that allows you to describe all those systems, no matter how complicated they are. So let me quickly give you a very, very brief introduction to event modeling so you know what we're talking about here, because event modeling is a fundamental piece of how I build systems. It's the biggest piece because I spend most of my time nowadays in Miro. I'm a software engineer by heart, but most of my time I spend in Miro. I don't spend it in code. I spend it in Miro, specifying how systems should actually work, not writing the code. This is what AI can do very well, but specifying the system, that is where we need real engineering principles. And I work with Miro, and you see that in a second how that works. And I just use these 5 key elements in event modeling. The first one is an event. An event is just something that happened in our system. Well, it's not something technical. When people hear event, they immediately think about event sourcing, they think about event-driven architectures and stuff like that. Nothing like that. An event is just something that happens in the system. An event could be that your marketing agent called a customer. A completely manual process. Still, this is an event, and this would be an event in the event model. This has absolutely nothing technical to it. The next thing we have a command. Command is just an instruction to the system. Something should happen, and the result of a command, if it's done correctly, is typically an event or several events. So they belong together. Then we have a read model. So the read model is just making sense of what already happened in the system. A read model just shows you how is information already available in the system used. How do we provide this information to a node, to a UI? How do we provide this information to an automation, for example? And what is an automation? It's just like a background process. Then we have screens. What is a screen? Well, just how do users make things happen in the system? What buttons do we have? What input elements do we have? What is the UX of our system? And last but not least, of course, we have the side effects of what already happened in the system. You have an event, and based on that event, something happens automatically in the system. This is all. All I need to describe any system in the world. You don't need more than this. Just these 5 elements. And if you combine these 5 elements into 4 simple patterns, you can really describe any functionality. So the 4 patterns are simple. One is a state change slice. We call them slices. A state change slice is just basically a combination of a UI, a command, and then one or several events. Basically, how does information get into the system? The next one is a state view. So state view just means we take all these events which are already in the system. And remember, has nothing technical to it. It's just information that is available. How do we use this information to, for example, display a screen, or how do we use this information to trigger an action in the system? This is what an automation looks like. Automations is basically just a combination of a state view and a state change slice. It's just 2 slices. We use information already available in the system, then there's this automatic process, and this automatic process is triggered by a certain state change in our system. And the last but not least, we have translations. Oftentimes, we not only talk about one system, we talk about many systems, and we are especially interested in how do these systems interact with each other. For this, I use external events. External events are yellow, so whenever you see an external event, a yellow event in an event model, you know there's data from another system entering our system, our bounded context, for example. That's all. These are all the patterns I use to describe any system in the world. And the great thing is, if you work with these patterns, what happens is you naturally divide the system into what we call slices. You see here just a set of slices that describe a business functionality, one slice after the other. And these slices are so small that they are perfectly for AI. AI works with those slices, and you see that in a second, how that actually works. But using event modeling, you break the system down into natural functional building blocks with a perfect size for AI. But to work with AI, we not only need the functionality, we also need the business rules. What are the business rules in our system? So if you click on a button, of course, you can describe the functionality. Oh, if you click this button, there is an email that gets sent out, for example. But typically, if you have this functionality in the system, there are business rules behind that functionality. So in event modeling, what we do is we use given, when, then. Of course, stolen from behavior-driven development. We describe the system and the business rules using given, when, then. So here's a simple example. Given nothing happened yet in the system, we just started the system. When I reserve this ticket, the ticket should be reserved. There should be a new reservation in the ticket. Same thing, given the capacity limit was reached for my ticket reservation system, when I try to reserve another ticket, there is an error. That doesn't work. This way you can describe any business functionality just by using these 5 elements here. But how do we now combine this with AI? What I will show you today is how I do that. It's called the Ralph loop technique. So maybe you remember Ralph Wiggum from The Simpsons. It's a very simple character, and the Ralph loop is a very simple approach. The whole implementation of Ralph loop is this. The whole idea of Ralph loop is you run your agent in a loop again and again and again and again. And you give it the same prompt again and again and again. Sounds crazy. And many people, because I write quite a bit about how I use Ralph loop on LinkedIn and in other places, and many people approach me and ask, what's the point? What's the point of Ralph loop? I don't get it. Running your agent in a loop? I don't get it. And that was exactly the same what I also said. When I read this article about Ralph loop, I didn't get it. What's the point? This is the point. After each iteration in your loop, you clear the context. This prevents context bloat. After each iteration, you clear the context. This means your agent is starting with a clean context every single time when you run it in a loop. And another very important thing, I'm talking about Ralph loop, we record the learnings in each iteration. So whenever you run a loop, there is a text file where your agent just appends, oh, this is what I learned in this iteration. And in the next iteration, we add more learnings to this file. So your agent is learning in each iteration. And this makes all the difference, because now it's no longer the case that your agent gets dumber and dumber the longer you work with it because the context fills up. No, your agent gets smarter and smarter with each iteration, in each loop. Because you add those learnings, and in the next iteration, you have more learnings. And in the next iteration, you have more learnings. So the longer you work with your agent, the smarter it gets. You record all those learnings again and again, and they apply to your project. And it's almost magical how well that works. So what we do now is we'll model a system together. We jump now to Miro. I will show you how I model a system very quickly. We'll generate some boilerplate code using a static code generator. I'll run the Ralph loop and we'll build some slices. Let's see how far we can get with this. We'll generate a front end with just one prompt. And after that, I'll show you the event models. And of course, at the end, we have time for Q&A. So the whole idea is not to build this whole system. What I want to do is I want to really show you the process, how I use those tools, how I combine those different elements together, and why it works so well for me. And of course, if you have questions, feel free to ask questions at any point in time. I will never stop talking. That's typically what happens in my webinars. I talk all the time. If you have a question, just shout it out. Interrupt me at any point in time. So let's jump to Miro. So first of all, what we do here is we have a simple use case prepared. So there's no code prepared, nothing. So we will really start with a very simple thing. That's our requirements. That's typically how projects start. Very simple requirements. Now, what typically happens is we go through 7 phases. And I will share this Miro board after the webinar so you can access this. If you look at the Miro board here, There's a whole lot of information available about event modeling, about the 7 phases of event modeling. So if you want to apply event modeling to your project, this is how you do it. Typically, you run through 7 phases in each and every event modeling workshop, and it's all documented here. So this is a great starting point if you just want to give it a try. The first thing we typically do is we do the brainstorming. The brainstorming just means get a whole bunch of people in the project together and try to extract as much knowledge as possible onto this board by just finding all the events that could happen in the system. That's all we do in the brainstorming. We cheat a little bit today, because what I will do is will use a little bit of AI to speed this process up. So what we have here is we have our requirements here. It's a to-do application, very simple. So I intentionally chose a very simple use case. It's a to-do application. Typically what happens, if I get the list of those requirements, the first thing I do is I build a timeline out of that with AI, because it's much easier to read a timeline than to read all this text. So let me see if that works now. I will just copy this thing here, and we will start over here. What you see on the left side, that's the event modeling toolkit. That's a Miro extension to use event modeling in Miro. So you can do event modeling without any tooling. You don't need the Miro toolkit extension, but this is just a tool that helps you a little bit and does things a little bit faster. So what I'm doing now, I just paste the requirements here and say, give me a timeline. It will now analyze the timeline. In the background, there is an AI that knows how to parse requirements, that knows how to understand requirements, and it will give me just a timeline here. And it's so much easier to read this timeline than to read all this text, because now if we look at that, I know, okay, what is written in those requirements. There is a to-do list that gets created, nice. There is an item that gets added to the list, also nice. Item marked as closed, item can be deleted, and the to-do list can also be deleted. That's all. That's our whole requirement here. Very simple. Now, what happens next typically in an event modeling workshop? When we have our timeline, we try to build the first slices, just by understanding what is happening in the system. And the next step I typically do is I draw some screens. Screens are a very essential part in event modeling, and screens that I draw are intentionally very ugly. So my super skill is drawing ugly screens. I'm perfect in drawing ugly screens. So let's see. My rule of thumb is I never use more than 2 minutes for a screen. If you need more than 2 minutes to sketch a screen, you're definitely doing it wrong. So this is my to-do list. And we would provide something like a name here with an input field like this, and a button to save. That's all. That's my whole UI. And if we save the to-do list, I want to have a list of lists here, down here. My list number 1, my list number 2, my list number 3. Just a list of already created lists. So I can maintain a list of to-do lists. Nice. That could be my screen. And now what we do is we would step by step decide what is necessary to build this screen. So we use the events, we use the screen, and then we just decide what is the information that is necessary and how do we get this information into our system. So in this case, the first thing I will look at is how do I get this list into my system? What is relevant for this? And I always mark this in the screens like this. So it's really clear, okay, for this step in the system, these are the elements which are relevant. The input field and the save button. Everything else, I don't care. I only care about this. So what happens if a user clicks this button? What we do is we fire a command into the system. And this command could be named, I don't know, add list, for example, something like this. In event modeling, you connect the elements. So you do it like this. The arrows between those elements, they show you how information flows. So here we see information is flowing from the screen to the command, and from the command to the list. What you also get with this tooling here is information completeness. Very, very important feature in event modeling, information completeness. At any point in time, you need to be clear about information completeness. Is my system information complete or not? This prevents you from making wrong assumptions. Assumptions is one of the biggest problems you face in your typical project. Here we see, for example, this arrow is turning red. Why? This is not information complete. The to-do list created event states, I want to have a name attribute, but we didn't define where this information is coming from. Same example for, I just had that recently. There was a requirement where we need the user email, and for the user email, we do the registration in our system. It turned out nobody knows where this user email is coming from. You cannot start with the implementation if you are not information complete, because it could be that this user email is coming from a completely different system. And maybe you need an API endpoint with a team that has a backlog filled with 3 months worth of work. So you will only get your new API endpoint after 3 months. This can block your whole system just because you didn't do the upfront work to check, is my system, do I have all the information I need? So I'm very, very strict about information completeness. You cannot start with your work until you are information complete. So in this case, what would we do? Very simple. The name is provided by the screen. So we can just copy the information here. It gets provided here by the command, and it also gets provided by the screen here. This is our first slice. We just defined our first slice. This could already be implemented. Now, what I could do is I could say, I make this a slice. A slice is just a border around this functionality here, but you could already implement this. You could already implement a screen. You could implement the API endpoint to accept the command. You could implement the persistence here. This could be event sourced. This could be anything else. Event modeling is not about technology, not at all. But today, of course, we will look at how to build this using an event-sourced app in Node. So, of course, in our case, this will be an event-sourced system. And the great thing is, if you combine event modeling with event sourcing, there is a one-to-one translation between your event model and the code. So it's very easy for static code generation. It's very easy for coding agents to translate the event model into code. Let's define a second slice here, because, of course, if we add an item, we want to update this list here. So in the next step, what I would do is I would just mark this list here, and this is in green, because now we are not giving information into the system. We are using information already available in the system, for example, to render this list. For this, we need a read model. So the read model here is just something like available to-do lists. Something like, we will only model this slice here, so this is not about event modeling alone. I just want to show you how you typically go step by step in your system. And then what you would do is you would just connect the event to the read model to the screen, and make sure that you provide all the information in your screen. So what do we need? What information do we need in our screen? It's the name of this to-do list here. And of course, again, we are not information complete. So we don't provide all the information, but in this case, again, we can make it very simple. We just copy everything, and this should hopefully work. No red arrows means we are information complete, so this would be my second slice. So last thing I want to show you is how do we define the given when thens. So in this case, we could have a rule, for example, that states I don't allow to-do lists with the same name in the system. So a rule could be just using a given when then. I could say given the to-do list was already created. When I try to create another to-do list with the same name, then I have an error which says can't have lists with same names, something like that. Spend a lot of time in event modeling, defining those given when thens and defining those business rules, because this is what's really, really valuable. And we don't do this alone. We do this collaboratively, together with business experts, together with people who really, really know how the system works. And the great thing is, if you do it like that, you can even start to chat with your requirements and verify that. So let's see if that works. So for example, I just need to give it a context for this. So this is my sample to do context. And I will add those slices to this context. Bear with me for a second. Now, what I could do is I could just check with my requirements and see, does this make sense? So I could say this is the sample to do, and I can just ask, are there any rules to add lists. So the event model just analyzes this, and you can chat with your requirements. And this is really, really great. If you have a bigger event model, you can just chat with your requirements using AI to verify what you modeled. And sometimes if the AI doesn't understand what you're doing, typically your model isn't clear enough. That's a very good indication if you are on the right track. So if you model this to-do application, I did that before we jumped into the webinar. This is something how this could look like, how this event model could look like. So here we have the UI for creating a to-do item. We fire this command here. Then we have this to-do list created event, and so on and so forth. So in the end, if you do event modeling right, you can read the whole system basically from left to right. You start on the left, and if you want to know what happens in the system, you go step by step, slice by slice to the right. That's typically how it works. So let me just remove this status here because we want to start from scratch. So now if we have the system here, and it's fully specified, and you also see there are quite some business rules here. So for example, one business rules we have in the system is I can only have 3 to-do items in one list. The given when then for this would look like given to-do list created, and given I have 3 item added events. If I now try to add another item, I have an error. I can only add 3 items. And again, you could just ask AI, does that work? Is that modeled correctly? Let's see if that works. How many items can I add to a list? You can add a maximum of 3 items to the list. The event model just looks at the agent just looks at the event model and sees these are the business rules that are defined. Very cool. You can chat with your requirement, and that's really an interesting way to work. But how do you now translate this to code? If you've done it correctly, you see the event model, but how do you get from the event model to code? And let me quickly jump over to a real world event model just so you see how big they can get. This is a real world event model. That's a real project. So let me zoom out. That's what a typical event model looks like. So you have different use cases here on the board, and you see every use case is defined step by step, slice by slice, including the business rules. So it's not only on a small scale, this can happen on a very, very large scale. So here, for example, this down here is license management. This is invoicing. All different use cases, but everything is on the same board. Here is case management. You see that's a lot. Step by step. This model is built together with business experts. This model is built partly with AI, but the whole system is described in the event model here. And if you zoom out, it's really big, and this is still work in progress. This is not done. In the use cases down here, you see a lot of screens. This is where we currently have discussions. How should that look like? How could that look like? That's how we are working with it. So how do we get to code from here? How do I use this together with AI? Now let's see. What you can do here is you can export this configuration, and that's exactly also the configuration you'll get in the demo repository. So you can export this whole event model here, and what you'll get is a big JSON. There's a lot of JSON in here, and this JSON just describes slice by slice what is specified here in my event model. And the great thing, it turns out this JSON is the perfect input for a Ralph loop. Now let me just export this. It should already be available. And let's jump over to IntelliJ quickly. So if you export this, what you'll get is first, you get this gigantic config JSON. So just for this small model here, it's a ton. A lot of stuff in here. Everything that happens in the event model is described in this JSON. But what you'll also get is, you'll get a breakdown in one file called index.json. And that's an addition that I added because of Ralph loop. That's basically your input to the Ralph loop. You see here, that's all the slices which are defined in my event model. And every slice here has a status. So here the status here is created. There's nothing to do for Ralph loop because the Ralph loop is basically, it's just, it's looking for slices which are in status planned. That's the tasks. So just think about it. It's running in a loop. and it's looking at this index.json, and it also always looks, is there one slice in status plant? And if that is the case, the slice gets picked up and gets implemented. That's how I use it. Now let's first do some static code generation, and then let's start the Ralph loop. I just want to show you how that looks like. So I work a lot with static code generation because it's very, very reliable. And it turns out if you have a well-structured system, you have repeating patterns all over the code base, especially when you work with slices and when you work with event sourcing. Those patterns repeat again. Every slice is just a copy of another slice. It's perfect for static code generation. Now let's just start this code generation, and you can also use this with the demo repository you get, because everything is available in there, including those code generators. You can just run it exactly as I'm doing it right here. So the code generator I'm using here is called Emmet Superbase, because this is specialized on using Superbase. But you don't have to use Superbase to use this. This is broken. Why is this broken? Because I'm in the wrong folder. See. So what I do now is I create the skeleton app. The skeleton app is just the template application for everything, but there is no code that gets generated. It's just a template. And what you also see here is you have the prompt. That's the prompt for the Ralph loop, and you have the Ralph loop itself. The Ralph loop is it's a bash script. So I'm not even using the built-in Ralph loop that you get with Entrophic and with Claude Code. It's just a simple bash script. It's running over and over this index.json and looking for slices which are in status plant. And if there is a slice in status plant, the loop picks it up and implements it. That's how it works. And the great thing is we already have the guardrails defined for the agent, because we have the given when thens here. The given when thens are the guardrails for the agent. You can generate them statically. That's what I typically do. You can also let the agent generate the code, but the logic, the business logic, is defined here. And this is a perfect guardrail for AI, because we just need to generate this test case and run it. And if it's green and it works exactly like specified here in the event model, you can be pretty sure that your slice works, because you didn't define those test cases alone. You defined them together with the business experts. Basically, your business knowledge becomes an executable specification in code. That's the best thing you can get. Let's see if that works. So first thing I'm doing now is I will just say, what is the slice that we start with? Let's just start with create to-do list. I want to implement. I could mark them all as planned if I wanted to, and I could just call it a day, come back tomorrow, and look at all the generated slices. But that's typically not how I work. Sometimes I do overnight, but let's just say we want to have 2 slices implemented. Create to-do list and the to-do lists slice here. I export this again. Let's go back here. Let's quickly check the index.json before we start the Ralph loop. So we see here, we have now 2 slices which are in status plant. All the other slices are still in status created. And now what I'm doing is I just start the Ralph loop. You see here, typically, if you don't put in anything, it's 10 iterations that it does. So after 10 iterations, it typically stops. And now we can just wait and see if we get a little bit of response here. If you just wait a little bit, maybe about 30 seconds, we should see the agent pick up the first slice and implement it. In the meantime, are there any questions I could answer until we get a feedback here? We still have 15 minutes.
Hi, Martin. Quick question. Did you generate the code with the code generator for the 2 slices, or is this Ralph is going to do it?
So typically I use a static code generator. In this case now, it's just I let Ralph generate the whole thing, the whole slice, including the scenarios.
Okay, thank you.
So no templates or patterns for it to follow. So it generates freely from the specification.
No, there is templates. So yeah, good point. No, of course there are templates. So what we have is there are skills defined for each slice type. There are skills defined, how to build a slice. There's a skill for a state change slice. There's a skill for a state view slice. There's a skill for an automation slice. So there's absolutely no room for interpretation. It's absolutely clear what a slice looks like, and typically it does exactly what is specified here. And now what you see here in the UI, just quickly, we see it picked up the first slice. Status went from planned to in progress, which means Ralph is currently working on exactly this slice. And it picked the first to-do list, the create to-do list slice. So typically, I don't specify which slice to pick. And if you look at the prompt, it says, pick the first slice that makes the most sense. So from all the slices which are currently in status planned, just pick the one that makes the most sense. And if you want to go really crazy, you can, of course, run as many Ralph loops as you want in parallel. So you don't have to run it just with one agent. You can run as many agents as possible. That also works with developers. So the great thing is if you have those slices, and those slices are independent from one another, that is the really important part, and that is why it works. Those slices are completely independent from one another. And this is why if you work with a sliced architecture like this and with event modeling, adding more developers or more agents to the project makes the project faster, not slower. Any other questions I could answer? While Ralph Loop is working. Yes.
So do you make an MCP to get the feedback to the Miro, or do you use Miro AI directly?
No,
API directly?
there is no MCP server here. It's really just there is a Docker container running locally, and this Docker container provides an API, and this API gets read here. So there is no MCP server or anything like that.
So it's the Miro API that gets used?
No, that's the Miro extension here. The Miro extension here just queries this status.
Okay, so it goes through. Okay, so it communicates with the Docker container, which is connected to here. Yeah, okay.
Yes,
thanks.
Exactly.
I believe you know this use case when Anthropic created compiler for C, recently, and they had the similar Ralph loop, but different from yours. Have you compared your implementation and their?
So the first implementation in Anthropic was not usable because what they didn't do is they didn't clear the context. So the longer you ran those loops, your context filled up over time. I think they fixed this in the meantime, but I don't see a point in this. So I'm really just using this.
No. I mean, in the article they posted, they even didn't use the Ralph loop of the Claude code. They used like some bash script or something like this, so similar like yours, but
yes,
but a little bit different. So I was wondering if you compared your implementation and their. They even run it in parallel using work tree or something like this.
Yeah.
So yeah, but a little bit different than yours.
So, I mean, there are many. Of course, there are many scripts for Ralph Loop, and I adjusted the script to my requirements because I have this JSON file. I need to read this JSON file and stuff like that. So of course I adjusted it, but I guess in essence it should still be the same. But I didn't look at it in detail.
The idea is similar.
Yeah. And of course, you can, using work trees, you can run really as many agents as you want. And you could even run the same agents in the same workspace. You don't even have, using this approach, you don't even have to use different work trees. They can all run in the same repository because those slices are independent. So this would also work. But of course, I mean, you want to, if you want to commit and stuff like that, it would still make sense. But just from a code base, you could run all those agents in just one in one repository. All right, what else? Any other questions? So it's still implementing here. It takes quite long. Let's see what's going on here.
Hey, Martin, I've got a quick question.
Yes, of course.
So to make sure, I've heard of the Ralph loop. I don't fully understand it. So what's happening here is you're feeding it the same data, but it's updating this file here and
yes,
something's been completed. You clear out the context and it's just starting from scratch.
Yep.
Taking the next one that's not completed and doing the thing.
Yes.
Okay. Great.
That's it. That's all. That's the whole idea.
That's great.
And you see here the first iteration is done. So the first slice is implemented. So if we jump now here, it should hopefully refresh in a second. So it's done, and it should now pick up the next just automatically. So we can have a look at the generated slice. So it generated the create to-do list slice, and you see here all those slices, they all look the same. So if you look at another project, all those slices look the same. They have the same 3 files every time. It's really crazy how simple that is. Now, what I do is what gets created here, we have a routes file. That's for Express. That's the API. This routes file has an open API specification. That is all defined in the skill file, and you get the skill files with the repo I sent you. So it's all in there. You can really you can do it exactly what I just did. Just run the Ralph loop and it will start to build. Here you have the command that got generated with all the files, everything in here, and also the test cases. So I didn't specify any test cases. So in my prompt is specified if a slice has no test cases, the agent can make test cases up itself. I will review it and maybe delete it, but if I don't specify any test cases, the agent is allowed to do that. It's not the case if there are test specifications defined, then it just has to do what is specified in the model. That's how I currently use it, and for me that works quite well. What also gets generated is, so this is the backend agent. So this is the backend agent. This generates the slice for the backend. What this agent does is it generates a UI prompt MD. And this UI prompt MD is the input for the UI agent. Of course, you also want to have an agent that works on the UI. So if you want to create the UI, there is an API. This UI prompt describes which API endpoints are relevant. So this is using a REST API. You have all the API endpoints in here. You have the payloads in here. Everything is described here, necessary to build the UI. What I typically do is I make a screenshot of the screens in the Miro event model, paste it also here, because unfortunately you cannot query those screenshots with an API. That doesn't work. So if you want to give it more input, you can use the screenshots. I just paste it here, and you can run the UI agent, and this builds the UI based on the specification here. And this works also really, really well. So we are now in iteration 2 of 10. You see here, the next slice is picked up. Now it's working on the to-do list. That's our second slice. And you can just leave. You can keep it running. So if your structure is well defined, and if everything is well defined, you can just keep it running overnight, build all the slices here, and just review tomorrow when you come back. Did everything work? And this is what I very, very often do. It's really amazing. Now, let me quickly show you a bigger project using this approach. Just want to show you the code structure, how that looks like. So here you see, that's a bigger project. And here you see the slices. Let's move this down a little bit. Same approach, same structure, also a node-based project, same Ralph loop, same prompt, same everything. And all those slices here are 90% built just using AI. And you see here, these are quite a lot of slices. See that? It's a lot of slices, and they are just here, one slice after the other. And if you look into those slices, they are exactly like this defined in the event model. So all those slices behave like very tiny modules or even microservices. They are standalone. They don't have any dependencies between each other besides the events. The events is the only thing that defines the contract between those slices, but everything else is completely independent. And this is why you can just keep them here. All those slices, and every slice is a very tiny business capability. Yeah, Christian, another question?
Yes, a couple of questions.
Yeah.
Normally, there's this learning record and the decision record in the Ralph loop, but I guess you don't need that too much. Or
what I do is, yeah, that's also a good point. Thanks for mentioning that. So what I do is, what I have is, there is the progress.txt file. It's also here. You can look at, it's called the build log here. You see basically what happened in each iteration. So Ralph, of course, logs what did I do, and also what did I learn. And what I do is, I use this progress.txt after each loop. and I record the learnings in the agents.md. So here, for example, these are the learnings that Ralph had. Now let's make this a little bit bigger. So this is a fresh project. Great. Yeah. It creates the context events because there were no events there. Some learnings about assert.empty. Great. State for simple. Create commands can be empty. Okay. npm install required before npm run build. Great. Nothing special, but those are learnings. And these learnings move to the agents.md because then in the next iteration, it knows this. This is gained knowledge over each iteration. So the progress.txt is basically the working file. You have everything that happens in an iteration in this file. And if you're done with this, all the learnings get compressed and into the agents.md. And then your agent gets smarter each iteration. That's what happens.
But what do you gain from, I mean, if you use static code analysis, it would just take one iteration, right? Then it will do it perfectly immediately.
What do you mean?
If you use a static code generator that just merge the parameters into the template.
Yes, of course. So typically I have static code generators for this. This was just to show. Because you have learnings. In each iteration, there's typically 1 or 2 learnings. But the longer you work, the smaller they get. So in the beginning, you have those very basic learnings that you see here, but later you just have, okay, in this special case, if this is a UUID and in the event model it's not a UUID, this is how we need to do it. And it's really amazing how well those agents learn. It's really crazy to see that. They really understand what happens and they really, really learn. It's really great to see that. And now we see only 2 slices were marked as planned, it's done, iteration is over. Yeah, Sven.
Can you explain what was given to the AI agent? So how do you give it the information of the slices from the mirror bar?
Oh, yeah.
And do you have other MD files with prompt parts that are used? So what is used to initialize the Ralph loop?
Yeah, great questions. So let's quickly go through the structure here. What is used here? So if you look at the index.json, there is a folder defined here. The folder defines, okay, where is the slice definition? Because here this is not the slice definition. This is just your work item. The slice definition is there's a .slices folder, and in the .slices folder there is the real slice JSON, and this is where everything in the slice is defined, basically. You have the command, you have all the fields, you have the types, everything is here, including the specifications. So if you look at the, what is it? Yeah, it's this one. Somewhere here is the specifications, and here's the specification, or you can only add 3 items, and this is exactly what we defined in the event model. And this is the real input for the agent. So the agent picks up this and uses this together with the skills defined to build this slice. This is enough. You only need this. That's your spec. The spec plus the skills is enough to build the slice, typically, including the business logic. So even if you have more complex business logic, that typically works very, very well. Of course, you need to review that, but oftentimes it just works. It's almost magical. So you ask also about the MD files. So what MD files do I have in my projects? Of course, we have so let's start with the Claude MD. Claude MD just gives the basic assumptions. Okay, this is what we use in the project. This is how it's structured and stuff like that. Development guidelines. That's in the Claude.md. Then we have the agents.md. Here is really, these are the aggregated learnings over all iterations. Everything is in here, so you see event management, stuff like that. Most of this is just the result of iterations. So I don't maintain this really manually. This is all AI generated, and typically the result of learnings. And you see there's a lot of information in here. What else do we have? We have the prompt MD. That's just the prompt. So you see here, currently my Ralph loop has 17 tasks that needs to be done. But yeah, that's basically it. So there isn't really more than that. And of course, the Ralph SH, which is the script that I run. That's basically what I do.
So in the agents MD, the AI records its learning, so that it's AI generated.
Yes.
And the Claude MD and the prompt MD are manually made.
Yes. They are static. They don't change typically, but the agent MD changes with each iteration. And so common gotchas, all you see here, that's all Claude generated. I don't do this manually.
Okay, and you said that the JSON that Miro generated is the base for the code generation. That means Claude needs to understand the Miro JSON,
That's basically, yeah.
and is able to interpret it.
Yes. So it's basically that is encoded in the skill files, and the skills is just defined. Okay, what does a slice look like? What is the input? And this is enough to interpret the JSON. Exactly.
So you have a skill MD to interpret the JSON.
More or less. So the skill files just describe what a slice looks like. So it describes this is a command, this is what a command looks like, and stuff like that. And that's enough. So there is no specific information here how to interpret the JSON because it's clear from the context. You don't need any special handling. It's just clear how to handle that.
But that are the instructions for the AI to interpret the Miro JSON.
There are no special instructions for the Miro JSON.
Okay.
It's just instructions how to build a slice, and the JSON is just the input.
Okay.
You don't need special instructions because it's very clear from the context typically.
Mm-hmm. Okay, thank you.
So any more questions about this?
Martin, if I wanted to run it with Axon framework, I just need to modify the Claude.md. Is that correct?
Oh, I have a setup for Axon as well. So I use this a lot with Axon on the JVM. That works. That is the very same thing. So
Okay.
different skill files, but the Claude MD, the Ralph SH, very same. Absolutely the same.
Okay, and I can use Claude or I can use GitHub Copilot. Does it really matter?
Well, this is specialized for Claude because you have the skill files and everything. But of course, you can adjust that for Copilot, of course.
Thank you.
So time is already up. So let me just quickly tell you what will happen now. So this also works for your team. If you want to use this in your team, you can try this. I can help you with this. If you want to try this with your team, just contact me. I'm very happy to help. And I will send to you, since you are registered for the webinar, you will get the link to the repository. This is the repository. You can also jump to it right here. There you find the Ralph SH. There you find everything. This is the link to the Miro board. You can access this. So you can really start to play around with this literally today if you want. You can just clone this repository, run Ralph SH, and it will start to build. If you have Claude installed locally, you don't need more than this. Any more questions about that before we close the webinar? That was a lot of information. Hope you took something out of it. Yes, Christoph.
Oh yes. How do you stop Claude from using all your tokens?
Oh, you can't. That's why you have the iterations. So you define 10 iterations, and after 10 iterations, it typically stops, and then you can either restart or yeah. You need to define how you do that. You could also, I think you can also ask for the available tokens, but I run 10 iterations, and after 10 iterations, it stops.
Thank you.
Yeah, now the other Christoph.
Hi, Martin. Thank you for the introduction of the Ralph loop.
Yeah.
I just was wondering if you also played around with spec-driven development.
Yeah, that's the very same thing. That's the very same thing. This is spec-driven development. The event model is your spec. I mean, you could also use something like Kiro or something, but that's the very same thing. So my tool of choice is just event modeling because it works so well. You could use any other spec, of course, as well. Doesn't make any difference.
Okay, thanks.
Anything else? Well, if not, so hopefully that was well worth your time. That's always important. Thanks for joining, and please play around with the Ralph loop. It's a lot of fun, and it's really a productive tool. All right, then thanks for joining, and see you next time.